This is question 6a, figure 6.1 shows a crassus of water wave moving from left to right in a harbor. And the question 1, or part I, on figure 6.1, draw 3 more crassus to the right of a point A. Okay, so after these crassus represent the wavefronts, and if you're not familiar to the wavefronts, it means that the line passing through all crassus. The distance between the two successive crassus we name wavelength. The problem of drawing, especially in waves, students sometimes they're not familiar with the phenomena. Here we are in front of diffraction. So the waves, after passing through a narrow gap or a barrier or an obstacle, they become slightly being curved. It depends on some factors like the size of the gap or the once you pass close to the edge or a harbor wall, according to the question here. So we draw the lines like this, slightly curved. So these are the 3 more crassus as the examiner request. And please do not forget after drawing the diffracted waves, here is to draw these rays. They represent the spreading out of waves after passing through or close to the harbor wall. The double I, the examiner is asking to state the name of the wave process that occurs as the wave passes point A. This one is, I already mentioned, is diffraction. Diffraction, it means the spreading out of waves after passing through gap or harbor wall through close to the edges of any or curved ends. So with this one, it means that we have a change in the shape of wave. There's no change in the wavelength or the frequency. Everything is constant except except the shape of the wave. In part B, figure 6.2 shows the crassus of another wave moving from left to right in a different part of the harbor. This wave moves it from deep water to shallow water. In part I, on the figure 6.2, draw an arrow to show the direction of movement of the wave after it has passed into the shallow water. Okay, so we'll move from the deep water to the shallow water, and these are the crassus, as we said before, represent the wave fronts and the distance between the two. Any two successive wave fronts or crassus represents the wavelength. And here in the shallow water, we have a decrease in the wavelength. So the speed decreases as well. Okay, anyway, then I is asking to use this figure and draw on it. So I'm going to draw the incident ray here. This one is the incident one, and I'm using the arrow. Okay, so secondly, you have to draw at the incident point the normal. This one must be drawn anyway, the normal, which is a perpendicular dotted line at the incident point. And look here, there is this line represents the separate surface between the deep water to the shallow water. Then uh, the examiner is asking to draw these waves through or the direction of movement. So this after drawing the normal. So these crassus of wave that pass into the shallow water. So this is the perpendicular line, which represents the direction of movement in the shallow water. Okay, guys, and which is always perpendicular to the waves or refracted waves. In double I, state the name of the process that occurs as the wave passes into the shallow water. As I said, they are refracted waves, so the name of the phenomena it's refraction. Refraction, it means in physics, it's a physical phenomena which explains there is a change in the speed of whatever is light waves or sound wave or water waves. So do not use the concept of changing the direction, which is preferable to use the idea of a change in the speed. Okay. In Triple I, complete table 6.1 to state whether each of the properties of the wave increases, decreases, or stays the same as the wave passes into the shallow water. The table 6.1 shows the three properties: the wavelength and frequency and speed. I know there is one formula linking these three properties. The v, which is velocity with the speed, equals to lambda for the wavelength times the frequency. Okay, shown here at the right. And you remember the previous diagram, what happened? The waves become close to each other in the shallow water. It means the spaces between wave or crashes or wave fronts, they slightly become less than the incident waves. It means the wavelength decreases. So this is the point one. This one, we are sure about this. Okay, the frequency, it means that the number of waves, number of complete vibrations of oscillation as incident as refracted, they are similar. There is no change at all in this example. So the frequency stays the same, the number of oscillation does not change. The third point, if we have in any mathematical calculation, if one factor changes, then the second one is constant, the third one must be affected by the wavelength now, which is the velocity, so the speed. So the speed of the wave decreases, and we get 3 marks. 1 mark for the wavelength, and the second one for the frequency, and the third one for the speed.